There we go. So hyperbolas look like this if you recall. Okay, so they're out to the sides this way, and there's two asymptotes that they cannot cross. Okay, either vertically or horizontally here. Okay, so we are going to graph those today using our standard form. So example 1, we have x minus 3 squared over 4 minus y plus 5 squared over 9 equals 1. And we want to identify these key characteristics. So first thing here, your a value in the denominator is always the first fraction. Okay, it's always in the first fraction. So this is your a squared value, and this is your b squared value. So seeing if this is vertical or horizontal, okay, since a is under x, this is going to be a horizontal hyperbola. Okay, next we want our center. So h again is always with x and k is with y. So here we have this minus 3. Remember, whatever's in your parentheses, we take the opposite sign of. So our h value will be 3, and our k value will be negative 5 as our center. Okay, now to find our vertices, we do need our a value. So to find a, since this 4 is a squared, we're just going to take the square root of that number. So a will be equal to 2. Same thing with b. Okay, we'll take the square root of that number. So b is equal to 3. Now your equations for your vertices here, since it's horizontal, we're going to take h plus a, okay, and h minus a, okay. So our h value is 3. We're going to add our a value onto that. So 3 plus 2 is 5. And then we'll keep k the same at negative 5. Okay, now subtract a. So we have 3 minus 2 is 1. And then again, keep k the same at negative 5. Next, our covertices, we use this b value here, and those are at h, k plus b, and h, k minus b. So our h value remains the same at 3. Then we're going to take our k value of negative 5, add on 3 to get negative 2. Same thing with our second point, so h stays at 3. And then we have negative 5 minus 3 is at negative 8. Okay, then our foci points are at h plus c, k, and h minus c, k. So we will have to solve for c. Okay, so to find what c is, we need to use the equation c squared is equal to a squared plus b squared. Okay, we can plug in our a squared value, which is just 4. Our b squared value is 9. And we want to add those together. To get c squared is equal to 13. Then we just need to take the square root of both sides. To get c is about 3.6 units. Okay, that way we can plug that c value in to each of those coordinates. So we're going to take our h value, which is 3, add on 3.6 to get 6.6, and then keep k the same at negative 5. Okay, then take our h value 3, subtract 3.6 to get negative 0.6, and then keep k the same at negative 5. Okay, so these are your key characteristics of your graph. However, in order to graph a hyperbola, you also have to find the slope of the asymptotes. Okay, so you want to find the asymptote slope. Okay, so I'm going to lay this chart here. So since this is horizontal, the equation for our asymptote, the slope is going to be plus or minus b over a. So we already have b and a, so we can figure out what this slope is pretty easily. So we have plus or minus b over a, which will just be plus or minus b is 3 over a is 2. Okay, so our slope for these asymptotes is positive 3/2 and negative 3/2. So we're going to go from our center point. So we're going to plot that one first at 3, negative 5. Okay, next I want to plot in my asymptotes. So I'm going to use my slope from that center point. Okay, so slope is rise over run. So I'm going to go up 3 and right 2 to make a point. Okay, so I have one asymptote here going this way. And I usually draw that in as a dashed line. Okay, from our center point, we also want the negative slope. Okay, so I can either go down 3 and then right 2, or I can again go up 3, but this time go left 2. Okay, from your center. Okay, I'll do one more, 1, 2, 3, left 2. Okay, so it's kind of coming in this way right here. And again, I draw those in as dashed lines. So these are your asymptotes. It makes it a little bit easier to graph your hyperbola if you know that slope. Questions so far? All right, next I want to plot the vertices. So I have a vertex at 5, negative 5, and 1, negative 5. Okay, so since these are your vertices, this is where you're going to draw in your hyperbola, and it should get closer and closer to that asymptote, okay, on either side here. Okay, same thing from the second vertex. Should be a little rounded, and then get closer to your dashed line for your asymptote. Okay, don't let it cross over that dashed line. It just wants to get closer and closer to it. Okay, you can also plot your covertices and your foci points. So I have a covertex at 3, negative 2, right there, and 3, negative 8, right here. And then my foci points at 6.6, negative 5, and negative 0.6, negative 5. Okay, so once you draw in those asymptotes, it's easier to draw in that hyperbola after you plot your vertices. It should just get closer and closer to that asymptote line. Questions? Okay, so in the equation for any hyperbola, the value of 2a represents the constant difference. This is the absolute value of the difference between the distances from any point on the hyperbola to the foci of the hyperbola. So any point on the hyperbola at the right will have the same constant difference of the absolute value of y minus x, or 2a. So it's just talking about that distance between your points there. So example 2, two receiving stations that are 150 miles apart. Okay, receive a signal from a downed airplane. They determine that the airplane is 80 miles further from station A than from station B. Determine the equation of the hyperbola centered at the origin which the plane is located. Okay, so these two receiving stations here that are 150 miles apart, that's using your foci, okay? They're focusing on those 2 points. They determine that the airplane is 80 miles further from station A than B. That's talking about that constant difference, okay? There's a plane on that hyperbola, another plane along the hyperbola on the other side. Okay, your constant difference between those points is always 2a. Okay, so this is your constant difference. Now, since it's centered at the origin, that means your h and k value are going to be at 0, 0. Okay, so I already know what the center is. That's 0, 0 because it said it was at the origin. Okay, then finding A, we were given that constant difference, and that constant difference is 2A. Okay, so we're finding A. So we would set 80 equal to 2A because it is our constant difference. And we could just divide by 2 to get A is 40. Okay, and since we're given the receiving stations are at those foci points, okay, foci is found using C. So we're going to find our C value in order to find that B value. So I can take that 150 is equal to 2C, because your distance between those two is 2C. So C is going to be 75. And then finding B, we use A squared plus B squared is equal to C squared. I know I usually write it the other way. So we're going to take that A value and square it, and our C value and square it. So our A value squared is 1600 plus B squared is equal to 5,625. And then to get B by itself, you would subtract here. So we have B squared is equal to 4,025. And then to get B, we would just take that square root. And I do want to just leave it in that radical form here. Okay, that way I can write out the equation of this hyperbola. Now, since this hyperbola is talking about the distance between these planes, we're just going to use our normal standard form, which is a horizontal hyperbola. So that means x is going to be over your a squared value. So writing out our equation then, we would have x minus our h value is 0 squared over our a value squared. So 40 squared is 1600 minus y minus our k value 0, that quantity squared, over our b value squared. So I left it as that square root so that when you take that square, it just leaves the number inside. And then that should equal 1. And again, you can write this differently. When you're centered at 0, 0, you don't need that minus 0 piece. So either way you write it is fine with me. I only have one more example for you for graphing these hyperbolas. So just like before when we had parabolas, circles, ellipses, we have to take our hyperbola equation and write it in standard form in order to graph it. Okay, so in order to write one of our equations in standard form, you do have to complete the square. So to complete the square here, I'm going to group all my y's and group all my x's together. So I have a 9y squared, and I have a minus 54y, so I want those next to each other. Same thing with this minus 4x squared. I want that other x value grouped with it, so plus 32x. Okay, and then I do have this constant of minus 19 here. I want to add that to the other side so that this is equal to 19. Okay, that way this part is grouped and this part is grouped. Because I want to complete the square for both of those pieces. Now in order to complete the square, I can't have this a value out front, so I have to factor it out from that quantity. So I want to factor 9 out from my y's. So I'm left with y squared minus 6y. And then here I want to factor out this negative 4 from my x's. Okay, so I'm left with x squared. And if I factor out a negative from a positive, it is negative. And that would be just 8x. Okay, now completing the square for each of these quantities, you do have to add in a value. Okay, so we're going to add in a value to both quantities here. And whatever I do to one side, I have to do the other. Okay? How do I find this quantity that I have to add in, or this value that I have to add in? Do you remember? Good. B divided by 2 squared. So my b value in this first quantity is negative 6. Divide that by 2 and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Okay, same thing with our second one here. We want to take our b value of negative 8. Divide that by 2 and square it. Okay, that's negative 4. Negative 4 squared is 16. Okay, so that's what I want to add into these blank spaces here. So I have 9 times y squared minus 6y plus 9 minus 4 times the quantity x squared minus 8x plus 16. Okay, now to get the quantities on the right hand side, you have to make sure you multiply. Okay, so multiply here. Okay, so I have 9 times 9 to get that first one of 81. Okay, and multiply these two values here. Okay, so I have negative 4 times 16. So that's negative 64. Okay, don't forget there's a negative out front here. Okay, so then you just need to factor out these quantities, and it should be a quantity squared. So I would end up with 9 times y minus 3 squared minus 4 times x minus 4 squared. And that will be equal to 36 once I add these three values together. Now, just like with ellipses, hyperbolas are always equal to 1. Okay, so right now it's equal to 36. So to make this equal to 1, I do need to divide each side by 36. Okay, and when I divide by 36 on the left here, I want to reduce this fraction, okay, in both cases. So whatever number you have on the outside of your parenthesis, that value should reduce to a 1. So my standard form here would end up being y minus 3 squared over 4 minus x minus 4 squared over 9 is equal to 1. Okay, so this value out front should reduce to just a 1 in both cases. Okay, then all we have to do is use that standard form like we did on the front to graph. Okay, so our center is at HK, and again, H is always with X. Okay, so H will be 4, and K will be 3. Since Y is over your A squared value, this is a vertical hyperbola. It's a vertical hyperbola. Okay, which one of my values here is A? 4. I have to use 4 here to find my A value. Okay, so A will be equal to the square root of 4, which is 2. And B will be equal to the square root of 9, which is 3. Okay, so the equation to find my vertices for our vertical hyperbola is HK plus A and HK minus A. So our H value will remain the same at 4. We'll take our K value of 3, add on 2 to get 5. Second vertice we have at 4, and then taking 3 minus 2 to get 1. Our co-vertices, we use B, so that formula would be H plus B and then K, and then H minus B and K. So taking our H value of 4, add on 3, that it's at 7, and then K stays the same at 3. Second co-vertice, we have 4 minus 3, which is 1, and then K is at 3 still. And then our foci points, we use C to find those, and that is at HK plus C and HK minus C. So using that C squared equals A squared plus B squared equation, our A squared value is 4, B squared is 9. So again, C squared is equal to 13, which is about 3.6. Okay, then we just plug those values in to find these coordinates. So we have H is at 4. Then we'll take K, which is at 3 plus C, so 3 plus 3.6 is 6.6. And then our second foci point, again, H is still at 4. We'll take K, which is 3 minus 3.6. So we have negative 0.6. And then what else do you need to graph this hyperbola? The slope of, what's it called? Asymptote. Okay, so since this one is vertical, your asymptote slope is going to be at plus or minus A over B this time, instead of B over A. Okay, and again, we already know what A and B are. So we're at plus or minus 2 over 3. Okay, then graphing this, you will need to plot your center point first. Okay, and our center point is at 4, 3. Okay, from there I can use my asymptote slopes to draw those in. So I'll do the positive one first. So we're going to go up 2 from that point and then right 3. Okay, you can do it again if you need to. So your asymptote is going through this way. Okay, then I want to do the negative slope as well. So I'll go up 2 again, but then I have to go left 3. Okay, so here's my second asymptote. So now that I have those 2 asymptotes in, I can plot my vertices so that I'm able to graph this hyperbola. So I have a vertice at 4, 5 and 4, 1. And since I know this is vertical and these are my vertices, my hyperbola is going to go up like this. So getting closer and closer to those asymptotes, but not touching. Same thing below here. Getting closer and closer, but not touching. Right there. Okay, and then you can just plot your covertices and your foci points as well. So I have a covertice at 7, 3. And 1, 3. And then foci points at 4, 6.6 and 4, negative 0.6. Okay, questions on graphing a hyperbola? So you still just have to find those coordinates in order to plot them. This one just has that extra step of finding the asymptote slope.